show that the function fz is not continuous at z equal to 0. So here's the solution. So one thing you guys need to understand is that the RE of z, that is the real part of z. So RE of z, which is if you know z is given as x plus iy, where x is the real part. So x, we write x as the real part of z, or RE of z. Okay, and then the other part is the imaginary part, which is the im of z. So what we have here is the real part of z. So we are going to write the original function in terms of x and y as f of z be equal to, so the real part is just x, so we write x over z, which is x over x plus I y. So this function is equivalent to the original one. Okay, so let's use limits to test whether or not the function is continuous at at z equal to 0. So the first part here, we're going to approach the point 0 along the y-axis where x is actually 0. So we have limit of z as it approaches 0, x over x plus iy. So this should be equal to, so we are going to use x, which is limit of the function as x approaches 0. So we write it like this. So we're going to have x over x plus I y. So this time we're going to substitute zeros everywhere there is x. So this should give us so we're going to have a 0 over 0 plus I y, like that. So this one is technically a 0. So let us approach the same point now along the x-axis where y is equal to 0. So we write limit of z as it approaches 0 for the function x over x plus iy. Okay, so this is equal to, actually we write in terms of y now. So y approaching 0 for the function, which is x over x plus iy. So if you substitute 0 where there is y, we are going to have x over x. So we're going to have x over x plus I, which is plus 0. So this is actually equal to 1. Okay, so we have two different limits for the same point. So clearly, the limit of the function as y approaches 0, so the function which is x, so the limit of x over x plus iy as y approaches 0 is equals to 1. And also the limit of the original function, which is the limit of x over x plus iy as x approaches 0 is 0. So as I stated, when you see the two limit points are not equal, 1 and 0 are not equal, so we can conclude to say therefore f of z, or the function, it is not continuous at x, at z equals to 0. So the function is not continuous at z equal to 0. We write equal to 0 there. You can consider subscribing to my YouTube channel as well as sharing my videos with your friends.